Yes, sir. So am I audible?
Hello, yes ma'am, you are audible.
Yes, sir. Can you please make me the host or co-host because
Yes.
screen sharing? Yes.
Now you are co-host ma'am, please.
Okay, sir. Okay. Okay, sir. Shall we begin, sir? Then 20 people are waiting, sir. Should we admit them all?
No ma'am, I'm looking in the
Okay,
meeting
sir.
room.
Okay, okay, sir. Okay, sir. So I'll begin.
Wait for a minute,
Yes, sir.
please
Yes, sir.
sir.
Okay, sir.
मैम रीनेम का ऑप्शन दो ना
What happened on Arkan?
सर जरा रीनेम का ऑप्शन दो ना
You have entered your name and
सर
mobile number.
गलत है नंबर गलत लिखे हैं
Rename yourself.
पानी में खींच कर ये पानी क्यों गिरा है नीचे में
क्या
चड्डी यहाँ क्यों है
ये सुखाई है, इसका गिरा है।
तो सुखाई है तो यहाँ क्यों सुखाई है बाहर नहीं जगह
बाहर सूखती ही नहीं है, 2 दिन से सूख रहा है।
श्रीवर्धन माइक बंद कर
Hello Bushra ma'am.
Yes, sir.
Ma'am, now you can introduce yourself and just start.
Yes, sir. All right. Good afternoon, everyone. Good evening, rather. My name is Bushra Sheikh, and yes, today I'm here in front of you. Today we are going to be talking about the very important topic in chemistry, that is isotopes, isobars, and isotones. Okay, like sir would say, these are the Amar Akbar Anthony of yes. Good afternoon, everyone. Yes, good afternoon, Badruddin. Okay, so when we talk about isotopes, isobars, and isotones, first of all, we need to understand that we're talking about the atom in general. Okay, so before we begin, what are the individual terms? We need to understand some important terms that are related to these atoms. Okay, when we talk about atom, the first and the foremost important thing is protons. What are protons? Protons are positively charged subatomic particles, right? In the, as we know that the structure of the atom, in the center we have the nucleus, right? The nucleus consists of the protons, which are the positively charged subatomic particle. Okay, the number of protons in an element is known as the atomic number. It is denoted by the letter Z. Then the next thing that we need to understand is neutrons. What are neutrons? Neutrons are the uncharged species that have no charge. All right. So to remember, how are we going to remember? We remember protons start with P. That means they are positively charged. Neutrons start with N. That is why you can remember them by no charge. Right? Protons are positively charged and neutrons are uncharged, or they do not have any charge. Both
Bushra
of
ma'am,
these,
excuse me.
yes, sir.
Who are allowed to in the meeting, please rename yourself and add your number with your name. I have enabled the option of renaming, please. like Faizan, Kunal Sarve, Rafi Ahmad, Rahid Qazi, Roshikesh Jagpal, Osama
मेरा
Qureshi,
तो नाम और नंबर लिखा
Vedant
है ना
Uz.
फैजान सिद्दीकी सर
There is another one with the name only Faizan.
आवाज क्यों नहीं आ रहा?
ओके सर
Please add your number, otherwise I will put them in waiting room.
फैजान सर आपका आवाज नहीं आ रहा.
सर आवाज तो आ रही है. हेलो.
हाँ बुशरा कंटिन्यू बुशरा.
Yes, sir. Yes, sir. Yes, Faizan, sir. All
Ask
right.
them to write proton का mass, proton neutron का
Yes, ma'am.
mass.
Please continue.
What does A denote? What does Z denote? Chat box में लिखो बच्चों लोग. मेरा आवाज आ रहा है
Yes,
क्या?
sir. Yes, sir. All right. Okay.
Continue.
Okay, so yeah, when we talk about protons, neutrons, please remember both of these together. There is a term that we use for both of them. And the number of protons plus neutrons in an element is known as the atomic mass number. Okay, it is denoted by the letters A. So whenever we are denoting an element, please remember there are these certain denotions that we use, Z and A, that we use for understanding an element. Okay, then we have the electrons, which are the negatively charged species, equal in a number as Z. What is Z? We talked about Z. Z is the atomic number. Indirectly, the number of protons and electrons in an atom is always the same. Okay? And lastly, we have the atomic mass, which is the total mass of an atom expressed in AMU. What does AMU stand for? Yes, everybody, please write in the chat box. What does AMU mean? What does AMU stand for? Yes, and finally we have, yes, correct, Ayush, atomic mass unit. Yes, very good. Atomic mass unit is the unit that we use to represent the atomic mass of an element. And finally, we have the nucleons. The term for protons plus neutrons in an element is given by nucleons. All right. So these are the basic terms that we need to understand before we move on with the subatomic particles. Okay. So electron, you all must have heard about the discovery of electron. This was a very famous experiment carried out by Sir J.J. Thomson. He investigated a cathode ray beam, and what he found, you all can see the green light. Okay, if you'll just yes, can you all see the beam of green light? That is the negatively charged electrons. All right, until then there was nobody was sure about what these electrons were or what were the subatomic particles in an atom. So J.J. Thomson investigated cathode rays and found out that cathode rays are a stream of very small negatively charged particles. Yes, Chaitanya. Yes, sure. I'll do it. I'll share the PPT. Yes. Okay. So he said that the negatively charged particles, which are 1837 times lighter than the hydrogen atom, these particles were named as electrons. So do you all know how did he understand that these were negatively charged? Yes, you all have studied about this cathode ray tube experiment. How did he understand? How did Sir J.J. Thomson understand that these were negatively charged? Yes? Anyone, you all can unmute yourself if you all want. How do we understand these are negatively charged elements, that the particles that were released? Okay. See, what happened was actually, if you all can see, yes, cathode ray tube. Yes. So how did he understand that these were negative, Gaurav? Okay. So what happened was he placed a beam, or he placed positively charged anode over here. And as we know, all right. Sorry, 1 second. Okay. So what he did was, yes, he used negatively charged anodes to show, and because, yes, as they went from positive to negative element, correct, it was attracted towards positive charge. Yes. As there was positive charge, so what happens was they moved towards the positive charge, and so he understood that these were negatively charged. Okay. So this was the famous experiment that led to the discovery of electrons. Next, we have the discovery of protons. In 1911, Ernest Rutherford found in his experiment of scattering by thin foil experiment that few particles bounced back. Right? You'll know this experiment. He concluded the presence of massive and positively charged nucleus in the atom, and he transmuted certain elements and found that hydrogen was always emitted. This hydrogen that was always emitted, it was then named as proton. All right. And finally, we have the discovery of neutron. Yes, gold foil experiment. Correct, Gaurav. All right. What about the neutron? How was the neutron? Yes, sir. Sir, your voice is not very clear. Can you please repeat?
Ask them to write in the chat box
Yes, sir.
about who has discovered proton, neutron, electron.
Yes, please write in the chat box, everyone.
What do you mean by atomic mass number? There are three things. What was atomic weight, equivalent weight, and one more weight, molecular weight.
Yes,
Amar Akbar
molecular.
Anthony. कितने लोगों को मालूम है बच्चों लोग एटॉमिक वेट ऑक्सीजन का कितना है, मॉलिक्यूलर वेट कितना है और इक्विवेलेंट वेट कितना है? कोई लिख के दिखाया क्या चैट बॉक्स में?
Yes. And finally, we have,
continue.
Yes, and finally we talk about the neutron, which is the third subatomic particle, which says that, you know, how these were discovered. Actually, you should know that Rutherford had already predicted that there is some uncharged particle that is present. But unfortunately, he could not state which it was, and he could not explain. He just gave a hypothetical explanation for the presence of an uncharged particle in the atom. But he was not able to recognize them as neutrons. And this work was done by Sir James Chadwick. Okay, in 1932, he measured the velocity of protons coming from a paraffin when hit by an unidentified radiation by beryllium. This unidentified radiation was actually the neutrons. And he determined the mass of these particles as that was same as that of a proton. Yes, very good, Srivardhan Aryan, correct. And he finally named these particles as neutrons. Okay. So this is the basic summary of understanding the subatomic particles. Okay, we have the nucleons and the electrons. The nucleons are actually the protons and the neutrons, and the electrons we know. Okay, if you had to remember, where is the nucleons, as the name suggests, they are present in the nuclear part of the atom. All right, if I had to just draw it for you, the basic structure that we are talking about, we have the nucleus in the center. Okay, this is N, the nucleus. And we have the orbits around it. Okay, these in which the electrons are present. So in the center, as we say, what do we talk? We say that the nucleons are present in the center, wherein the protons are also there and the neutrons is also there. And the electrons are present in the extranuclear part, that is, they are present in these orbits. Okay, they are present in these orbits around the nucleus. All right, everybody clear? Okay. Now, okay, so I'll just give you all a basic summary of all of these. We have the name, the symbol. This is the most important table that you will find for, you know, all the subatomic particles. We have the absolute charge, relative charge, the symbol for each of them, the masses, the atomic, the mass in kg and mass in U. What does U stand for? Yes, what is the unit U stand for? Yes, Vedant, correct. What does U stand for? U is different than AMU. AMU was the atomic mass unit. What is U that stands for? Yes, Ansh? Correct, Dhruva. The correct answer is Dalton. Mass in U is the Dalton actually that we talk about. U is the denotation for Dalton. And that is the unit that we use for mass. All right. And the approximate value or the approximate mass per unit is also given. Yes, according to the Dalton's atomic theory. Correct. All right. Everybody noted these. So this is the mass that you'll need to remember. Okay. Which of these is the smallest in size? Yes. Which of these has the least mass? The electron, the proton, or the neutron? Yes,
Electron.
it is 10 raised to minus 31, and that is the smallest subatomic particle. All right. Now what we come to see, when we are representing an element, please understand we represent them like this. Okay. So X is the atomic symbol, right? You all should know the atomic symbols of almost all the elements, all the important ones especially, and also know that they are different from the common names that we use. Like you all understand, if you all know Na is the symbol for which element?
Sodium.
Yes, but sodium actually it should have been S or SO something. But why is it Na?
Its Latin name.
Yes, what is the name?
Sodium something.
Sorry. Yes.
Natrium.
Yes, correct. Natrium. Natrium. That is the actual Latin name for Na. And that is why we name sometimes the symbol is giving according to that. Okay, like we have Hg for mercury. Then we have gold is Au. So depending upon that, lead is Pb. You all should know why we use these symbols instead of the common names that we are using. Okay. And also we have A is the mass number as we talked about. And Z is shown as the extreme bottom left. It is shown that is the number of protons in an atom. Like I've given for carbon. Okay. Carbon is 12,6. And we talk about carbon like this. Okay. Whenever we are representing, we're representing carbon as carbon 6. And 12 is the mass number of carbon. Clear, everyone? Okay. We'll just go through the Rutherford's experiment. That will be very, very easy for us to understand isotopes, isobars in general. Okay. Right. This was the plum pudding model. Who gave the plum pudding model? Who proposed the plum pudding model? Yes, Srivardhan. Correct. Auric is for gold. Yes, hydrogenium is for silver. Correct. Aurum is gold. Yes. Who gave the plum pudding model? No, Dhruv. Rudresh, please check. Okay, yes, correct. J.J. Thomson had given the plum pudding model in which he stated that the entire nucleus is, as the positive charge is the complete pudding, and in that the plums that you have, those are the negatively charged electrons. Okay, they're randomly scattered all over the positive charge. Okay. Now when we understand what actually Rutherford did was, he came up with the most accurate atomic structure. Okay, this was actually not the correct structure for the atom. So when we talk about Rutherford's atomic model, if you all understand, in 1911, Ernest Rutherford, what he did was, yes, Gaurav, watermelon also, he did the gold foil experiment, okay, in which he took a radioactive substance here. Okay, all these three scientists together, they carried out the Rutherford, but it's given after Rutherford's name, okay, because he was the lead in charge. So we have a radioactive substance. If you all can see the spherical ball in the center, yes, that is the radioactive substance which releases out radius. Okay, that is the source of alpha particles, and there's a lead container. Okay, so the alpha particles. Yes, what are alpha particles and why did he choose alpha particles was because they all contain positively charged and they were high energy molecules. Yes. Okay. So what should have happened is, see, when we talk about a high energy and heavier than electrons, what happens is whenever we talk about a heavy substance, it should directly pass without getting interrupted by the smaller particles that are present in the atom, right? Suppose we are considering any heavy particle, like for example, a car, okay? Will a car be stopped by anything small, like a stone, a small stone? Will it be able to stop the entire car? No. Why? Because, yes, that is not possible because it is much, much heavier than the stones, right? So similarly, what his theory was, what Rutherford's theory was, that whenever I take a heavily charged and a high energy charged particle, it will directly pass through the atom without any obstruction. Okay, this was his theory. And then he wanted to carry out the experiment. If you all can see, there was a gold foil. Why did he choose gold foil? Yes, does anybody know the answer? Why did he choose gold foil for the experiment?
Because
Its particle are larger in size.
Okay. What else?
it is the thinnest.
Yes, see, whenever you take about, consider, yes, because there are approximately 1,000 atoms if you take in 1 gram of gold. Okay, there are approximately, he considered that, if I take a very thin sheet, yes, they are very thinnest also. And there are approximately 1,000 atoms. Now, because he had a proper number, he said that, I would be able to calculate for each atom. I would be able to keep a record of each one of them. Okay, and that is why he considered gold foil. He had a reason behind taking everything very carefully, right? Thinnest gold sheet, correct, Srivardhan, very good. It is most ductile and malleable. And this was a fluorescent screen which on hit by radiation, it would spark or it would give some coloration. Okay. So you'll know his famous experiment. You know what happened? Most of them went straight. Some of them bounced back. And that is why he was not able to understand. And finally, he came up with a structure which said, yes, this was the experiment that he found, that non-deflected particles, most of them went straight. Some of them were deflected and some of them bounced back. This was because he said that most of the atom, in the atom, most of the particle or most of the space is empty. And that is why there was no obstruction and they went straight. Okay? Right. Now we have Bohr's atomic model. I'm sure you all are well aware of this. Yes. Yes, very good, Devray. Thank you. Most ductile is platinum and most malleable is gold. Okay. All right. Now coming to our most important topic, we talk about isotopes, isotones, and isobars. Having talked about everything about the atom, now we are in a position to understand each one of them in detail. Okay. So when I talk about isotopes, what are isotopes? Isotopes are variants of an element having the same number of protons but differ in neutron number. All right. Please take a note of this. How will you remember? Please understand the P in isotope. From that, you can remember P stands for protons. So that means they have the same number of protons. Okay, everyone? A simple method to remember isotopes, it contains the letter P. P stands for protons, and that is how you'll remember they have the same number of protons. For isotones, we have to consider the letter N. That is neutrons. So isotones will have the same number of neutrons. Right? Isotopes are variants of elements having the same number of protons but differ in neutron number. It was discovered by the radiochemist Frederick Soddy in 1913. Okay. All right. So if I say that the number of protons will be same, that means what is same? Which number will be same?
Atomic number.
Very good. The atomic number will be same, and what will be different? Yes. What will be different?
Mass number.
Mass number will be different because the number of neutrons is also different, right? But for isotones, they have the same number of neutrons. So obviously, they will be same elements or different elements. For isotones, they will be all of the same element or all of the different elements. Yes? Different elements. Very good. Yes, they'll be different elements. Why? Very good, Vedant. They'll be different because when we talk about them, we need to understand that the number of protons is different. And when we place them in the periodic table, we are placing them according to the number of protons. Yes, and because their number of protons is different in isotones, that is why they are different elements. Okay. It was discovered by, please remember these names. It was discovered by whom? Yes, and isobars, finally, when we talk about isobars are atoms, I'm extremely sorry, here it should be isobars, are atoms of different elements have the same number of nucleons. What are nucleons?
Protons plus neutrons.
Yes, so what will be same in case of isobars? The mass number will be same or atomic number will be same? Yes, yes, correct. Mass number will be same.
आइसोबार्स के लिए आपने क्या लिखा है?
Yes, for isomers, isotopes.
नहीं, आइसोबार्स के बारे में बात कर रहा हूँ मैं.
Isobars, I've written isobars. It should be isobars, sir. Here it should be isobars. Yes, isobars are atoms of different elements that have the same number of nucleons. That means they have the same number of protons and neutrons.
Actually, इसको सिंपल तरीके में आप लिख सकते हैं. जैसे आइसोटोप्स के लिए सेम Z डिफरेंट A, और आइसोबार्स के लिए लिख सकते हैं इट इज सेम A एंड डिफरेंट Z.
Okay, sir. Okay, okay.
और आइसोटोन्स के लिए इट विल बी सेम N and different A and Z.
Yes, sir. Can you please tell me? I'll write it for you. Same A.
देखो आइसोबार सबसे पहले आइसोटोप्स के लिए.
Yes.
same Z
Same Z.
and different A.
Yes, sir.
अब आइसोबार्स में
Okay.
आ जाइए, इसको
जी.
उल्टा कीजिए. It is
Yes.
same A, different Z.
Okay.
और आपको यहाँ पे आइसोटोन्स के लिए लिखना है
Yes.
same neutron number, that is same N
Yes.
and different A and Z.
Okay, sir. Thank you.
Yeah.
Yeah. All right, everybody, please take a note of this. Yes, this is a very simple shortcut to understand actually. You know, same Z, A, different A. The opposite is for isobars, same A but different Z. And in isotones, you will remember same N but different A and Z. All right, everybody clear with this? Okay. Now we'll talk about isotopes. Okay. Isotopes of an element. Okay. Isotopes of an element have the same number of protons but different number of neutrons in the nuclei. Like Sir said, generally, I'll again write it over here. So they have the same Z but different A. All right, please remember what is Z and what is A, right? They have the same position in the periodic table. Now, because they have the same Z, what is Z? Yes, what is Z?
Number of electrons.
Yes, or number of protons. Yes, because they have the same number of protons and same number of electrons. That is why what happens is they have the same position in the periodic table. Because we know that we have classified the elements in the periodic table based on their positions, right? And so because they all have the same Z, that is why they'll have the same position in the periodic table. Okay? Right, I've given isotopes of hydrogen and isotopes of oxygen. Okay, so as you're aware how many neutrons are present in hydrogen or in protium? The other name for this is also protium. Yes, how many neutrons are present in hydrogen 1? How many neutrons are present in hydrogen 1? Yes, please tell me. Okay. All right. I'm getting some of you are saying yes. The correct answer is 0. In hydrogen 1, that is the other name for hydrogen 1 is protium. Okay. Protium does not contain any neutron. Yes. Very good. It contains only one proton, but there are no neutrons. Right. So please write in the chat box, everyone. Yes, for protium, write 1 proton plus 0 neutrons. Yes, for protium, right? 1 proton plus 0 neutrons. For hydrogen, what is the case? How many protons and how many neutrons do we have? Yes, and please write for tritium also. So, you all should know for hydrogen that is protium, deuterium, and tritium. Yes, 1 proton plus 1 neutron in deuterium. And for tritium, we have 1 proton plus 2 neutrons. Okay, excellent. Yes. For isotopes of oxygen, all right, we are talking about 2 oxygen isotopes, that is 16 oxygen and 18 oxygen. Yes, how many protons and how many neutrons are there? I've already written. For oxygen, as you can see, there are 8 protons and 8 neutrons in oxygen 16. Yes, for oxygen 18, we have 8 protons and 10 neutrons. Okay, can you write the isotopes of carbon? Please, everyone in the chat box, please mention the 3 isotopes of carbon. Yes. Okay. Prathamesh, you're talking about diamond. Diamond is an allotrope of carbon. Okay, no problem. Yes, that is an allotrope of carbon. We're talking about the isotopes. Yes. All right. Yes, correct. We have 3 carbon. Yes, allotropes are diamond, fullerene, and graphite. Correct. Okay. So for all those who know that whenever we talk about, yes, one second. Whenever we talk about any element, right? In general, we don't specify the isotope that we're talking about, right? We only talk about a specific, like we say hydrogen. Now, we know that there are 3 isotopes of hydrogen. So whenever we're talking about hydrogen in general, which is the isotope that we are considering? Yes. How will we understand? Yes. Very good, Devrai. Correct. And how will we understand or how will we decide which one that we are talking about? Yes, Rishikesh, Prathamesh, how will we decide which isotope are we talking about? Yes, the term that comes into existence or that comes into picture over here is the next term, that is natural abundance. Okay. What do you mean by natural abundance? Natural abundance is actually the amount of that particular isotope in nature. Okay. Whenever we talk about hydrogen, please remember the most common isotope or the most common form of hydrogen is the hydrogen 1. Okay, and its abundance is 99.972%. Please write in the chat box the abundance of all 3 isotopes. Yes, very good, Devrai. The percentage of element or isotope in nature is known as the natural abundance. Yes, please write the abundance of all the 3 isotopes of hydrogen, and the one that is present in the most common form or the one which has the highest percentage of abundance, that is the general that we're talking about. Yes, thank you, Ziad. Correct. So, hydrogen, if you all know, hydrogen 1, as I said, its natural abundance is 99.972%. Yes, and that is why whenever I refer to the term hydrogen, please remember I'm talking about hydrogen 1. Correct, Rishikesh. And what about the other 2? What about deuterium and tritium? Yes, thank you, Vedant. Correct. Yes. Also, please write the natural abundance of oxygen 16 and oxygen 18. Okay. And which is the common, whenever I'm talking about carbon, which is the isotope that we refer to? What are the 3 isotopes of carbon? Firstly, please write that. And also write, yes, Devrai, thank you. We are talking about carbon 12 because that is the most abundant form of carbon. Yes. Yes, Raj, very good. Okay. Now that we have understood, please remember how our isotopes form. So parent isotope, whenever we talk about isotopes, yes, we are talking about in general, how are they formed? For that, we need to understand the radioactivity. Okay. Whenever I'm talking about radioactivity, please remember an unstable parent, it generally breaks down into the stable daughter and an alpha, beta, or gamma particle. Okay. So whenever we are talking about radioactivity, what happens is an isotope breaks down and there is nuclear fission. Please write the 2 types, nuclear fission and nuclear fusion. So depending upon what occurs, nuclear fission means the parent isotope breaks down into a stable daughter, and along with that, we also get an alpha, beta, or gamma particle. Alright, I've given the website, you all can refer to that and you all can understand everything about isotopes. Yes, chain reaction. Yes, nuclear fission. Please check the spelling of nuclear. Yes, nuclear fission and nuclear fusion. Correct. Thank you, Vansh. Correct. Nuclear fusion means combination and nuclear fission stands for division. Yes, so here as in the picture you can see there is breakdown. So that is why we are referring to fission over here. Okay. We are breaking down the parent isotope into its smaller daughter and an alpha beta particle. Okay. So this is fission because there is breaking down of particles. But as far as the opposite is concerned, that is fusion. Okay. Now we talk about isotones. What are isotones? Yes. Yes, thank you, Vedant. The isotopes of oxygen. Yes, Vedant, can you please just send it to everyone so that everyone can read it? Yes, isotones. What did I say? Yes, sir, already talked about it. What is the short form to remember? Isotones has same N, different A and Z. All right. That means the number of neutrons is same. The atoms of different elements having the same number of neutrons in the nuclei are called isotones. Example, 11 boron and 12 carbon. As the number of protons is different, they have different positions in the periodic table. All right, can you all please talk about boron? How many protons and how many neutrons are there in 11 boron? Yes, please answer in the chat box. How many protons and how many neutrons are there in 11 boron? And the same for 12 carbon also. How many protons? Yes, Devra. Okay, we have 11 protons and 12 neutrons. Okay. Yes. So 11 protons and 12 neutrons, correct. And what about carbon 12? Carbon 12, what is the number of protons and what is the number of neutrons? Yes, very good, correct. Okay, Devra, very good. Protons and neutrons both are 12 in case of carbon. Okay, so as we understand, what is happening is both of them contain 12 neutrons each. Yes, Rishikesh? What do you mean by 8p? Where are 8 protons present? Can you please explain? Yes, Rishikesh. See, both of these, that is boron as well as carbon, both of these have 12 neutrons each. And that is why they are termed as isotones, right? So what are isotones? Isotones are those elements which have the same number of neutrons, okay? All right. Yes. So, like for example, I've taken, we have oxygen, we have nitrogen, and we have carbon. Okay, please understand the isotope that we are considered. Carbon, I've taken carbon 14, and nitrogen, I've taken nitrogen 15, and oxygen 16. All three, as you can see, all three have the same number of neutrons, that is, all have 8 neutrons each. And that is why they are called isotones. Please remember, the main focus is on the term N, which means the same number of neutrons. Okay? And lastly, we talk about isobars. What are isobars? The atoms of different elements having same mass number but different atomic numbers are called isobars. Right? So what is same in case of isobars? If you have to remember, you remember they have the same A value but different Z value. Okay? Yes. Isobars are different elements and hence occupy different positions in the periodic table. Can you all give me examples of isobars? Yes. Very good, Devrai. A is same, Z is different. For isobars, correct. Yes. Like I told you,
how many isobars are there? Bushra?
Yes, sir.
तीनों isobar का कोई example दिया आपने argon का इसके अलावा?
Argon, potassium, calcium.
आर्गन कौन से ग्रुप में आता है बच्चों लोग? आर्गन
नोबल गैसेस।
हाँ, और पोटेशियम कौन से ग्रुप में आता है? पोटेशियम, पोटेशियम कौन से ग्रुप में आता है? पोटेशियम
अल्कलाइन ग्रुप।
अल्कलाइन ग्रुप। कॉस्टिक पोटैश किसको बोलते हैं? कॉस्टिक पोटैश। कॉस्टिक पोटैश किसको बोलते हैं? हाँ, और ये सी कैल्शियम हाइड्रोक्साइड का फॉर्मूला लिखो। कैल्शियम हाइड्रोक्साइड का फॉर्मूला लिखो। हाँ, के वो एक छोटा नाम कैल्शियम हाइड्रोक्साइड बराबर है। उसको दूसरा नाम है स्लेट लाइम। स्लेट लाइम लिखो। कंटिन्यू पूछो। ये अल्कली और अल्कलाइन में फर्क क्या? अल्कली और अल्कलाइन अर्थ मेटल में फर्क क्या है? ऐसा क्यों बोलते हैं अल्कली मेटल दूसरे को अल्कलाइन अर्थ मेटल क्यों बोलते हैं? किसी को पता है क्या क्यों बोलते हैं? कैल्शियम हाइड्रोक्साइड का इक्विवेलेंट वेट कैलकुलेट करने आता क्या? पोटेशियम हाइड्रोक्साइड का इक्विवेलेंट वेट कैलकुलेट करने आता क्या? कॉस्टिक सोडा किसको बोलते हैं? कॉस्टिक सोडा ठीक है बुशरा, कंटिन्यू.
Yes, sir. Okay, so isotopes, I hope everybody is clear with all the three terms: isotopes, isobars, and isotones. Okay, how will you remember? To remember isotopes, P, pay attention towards the letter P. That means they have the same number of protons. Okay, so Z is same, A is different. All right. For isotones, N, pay attention towards the letter N, which stands for neutrons. The number of neutrons is same. They will have the same N but different A and Z. Okay, and finally isobars. How will you remember for isobars is they have this same A value but different Z value. Okay, everybody clear? All right, I've taken some questions. Yes. Okay. Lastly, we'll talk about one important term, that is isoelectronic species. Okay, what is isoelectronic? As the name suggests, iso means same, electronic means they will have the same number of electrons. Okay, so isotopes, isobars, isotones, and isoelectronic is also one that comes into the picture. Okay, the atoms or ions of different elements having same number of electrons are called isoelectronic. Okay, the electronic configuration of isoelectronic species is the same. I hope everybody all can write the electronic configurations. Which are the four orbitals that we consider while writing the electronic configuration?
KLMN. KLMN.
Orbitals.
SPDF.
Yes, correct. We talk about SPDF. Yes. S, yes. What does S stand for? Yes, why do we call them SPDF? Yes, correct. What does S stand for? What does P stand for? What does D stand for? And what does F stand for?
Principal, diffusion, fundamental,
Yes, what is F?
and sharp.
Okay. So when we are talking about the four orbitals, please remember we have S, P, D, F. All right. And according to them, we also have the quantum numbers. What are the four quantum numbers for the electronic configuration? Yes. What are the four quantum numbers?
Ma'am, principal quantum number, azimuthal, magnetic,
Yes, and electron spin. Right? Yes. Sharp, principal, diffuse, and fundamental. Yes, correct. Very good. Those are S, P, D, F. S stands for sharp, P stands for principal, D stands for diffuse, and F stands for fundamental. And the four quantum numbers are principal quantum number, azimuthal, and you have magnetic orbital, and finally you have electron spin quantum number. All right. Depending upon these, we are able, or we can write the electronic configurations. All right. You all should be familiar with Aufbau's principle and Heisenberg's uncertainty principle, also Pauli's exclusion principle. Yes, very good, Rishikesh. Thank you. Principal quantum number, azimuthal stands for L. Magnetism is given by ML. And the L, please don't forget, that is written as a subscript in magnetic quantum number. Yes, and finally we have spin quantum number. Okay, so if you all are able, can you all please tell me for K, what will be the electronic configuration for K plus? K plus ion, what will be the electronic configuration? Yes, what will be the electronic configuration for K plus? Yes, very good, Gaurav. Correct. Okay, Devra, excellent. Same as argon. And then you tell me what is the answer for argon. How do we write the electronic configuration for argon? Correct, 288. Okay. All right. Yes. Can you tell me in terms of orbitals, please? Can you tell me as 1s2, 2s2? In those terms, can you please write the electronic configuration for K plus? For K plus and argon, please remember when you understand. Gaurav, yes. Okay. When we talk about that, right? Yes, let me tell you all. We talk about 1s2, 2s2, 2p6. Then what do we have? We'll have 3s2. Yes, Devra. 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. Correct. That will also be that electronic configuration for argon. Okay. Both of these, because K plus, please remember not K, but K plus is the isoelectronic species with argon. Okay. Not K. When you remove one electron from K, you will get K plus, and that will be an isoelectron species with argon. Yes, very good, Rishikesh. Okay. So, understanding all these four terms, we come to the first question. Protons and neutrons are bound in a nucleus by dash. Which is the most appropriate answer to this? Can you please tell me? Protons and neutrons are bound in a nucleus by dash.
Let one of them answer it. Bushra.
Yes, sir.
ये आंसर बोले सर, क्या है आंसर? क्वेश्चन देखो सर, बताओ उसको क्वेश्चन. प्रोटॉन्स और न्यूट्रॉन्स से चेयर पे बैठे हैं. ये देखो आंसर बताओ सर, क्या आंसर है? प्रोटॉन्स और न्यूट्रॉन्स आर बाउंड इन अ न्यूक्लियस बाय व्हाट? क्या आंसर है सर इसका? वीक इंटरेक्शन पढ़ जरा. क्या? शॉर्ट रेंज स्ट्रॉन्ग इंटरेक्शन, लॉन्ग रेंज इलेक्ट्रोमैग्नेटिक, लॉन्ग रेंज ग्रेविटेशनल. कौन सा रहेगा? हाँ श्रीराम, कौन सा आंसर है? दूसरा चेक कर, ऑप्शन में सब लोग बी बोल रहे हैं. बी राइट है क्या?
Yes, sir. Yes, sir. B is correct. I'm sorry. Okay. Oh, sorry, sir. B is correct. Why B? Because the correct answer is B. Because if you check, these are the four fundamental forces in nature. ठीक है? Strong है, then we have electromagnetic, then we have weak, and we have gravity. So strength सबसे ज्यादा कम gravitational force की है sir. Then we have the weak forces. फिर उससे कम है सबसे strong forces जो आते हैं, those are the strong short range strong forces. So B option is the correct answer. The force which holds together the nucleus, that is responsible, and that is the strongest force. Yes, that is the strongest force. Correct. So
very fantastic slide. इसके ऊपर जरा explain करना है slide. बच्चों लोग ये बहुत काम का है, NDA के हिसाब से बहुत काम का है.
Yes, sir.
Strong मतलब उसका रेंज कितना रहता है? 10⁻⁻15 diameter.
हाँ.
ये क्या है? इधर बता ना, ग्लूऑन्स क्या है? ग्लूऑन्स बुशरा.
हाँ, yes sir. So one second. ग्लूऑन्स और जो न्यूक्लियॉन्स रहते हैं ना, न्यूक्लियॉन्स मतलब प्रोटॉन्स और न्यूट्रॉन्स, वो क्या करता है ना, जो दिस फोर्स इज ओनली रिस्पॉन्सिबल, इतना शॉर्ट रेंज है, इतना फर्म है वो, कि एक्चुअली इफ यू चेक, यू नो, न्यूक्लियस में क्या होना चाहिए, बिकॉज देयर आर ओनली प्रोटॉन्स, इसके लिए लाइक चार्जेस है, सब पॉजिटिव है, जो उसमें रिपल्शन होना चाहिए, एंड द प्रोटॉन शुड, द न्यूक्लियस शुड नॉट बी हेल्ड टुगेदर, वो टूट जाना चाहिए या फिर कोलैप्स होना चाहिए. बट because there is strong force, short range strong force of interaction है, which holds together the nucleus, इसके वजह से nucleus does not break down. And again, when we talk about, one second, when we are talking about gluons,
इसके बारे में बता ना, ये strength 1/137 किसका? 1/137
electromagnetic.
हाँ, उसका मास 0 और स्पिन 1 है क्या?
हाँ, वो फोटोन का दिया हुआ है सर, फोटोन का मास 0 है.
न्यूट्रिनो के बारे में बच्चों को पूछो ना, न्यूट्रिनो क्या होता है?
न्यूट्रिनो तो हाँ पता.
और ये तूने जो GeV लिखा है, जी मतलब क्या? गीगा क्या? मेगा इलेक्ट्रॉन वोल्ट के साथ गीगा.
यस जी गीगा.
गीगा का कितना वैल्यू रहता है?
और ग्लूऑन सर, जो ग्लूऑन आप पूछ रहे थे ना, वो ग्लूऑन इज व्हाट? इट इज द बिटवीन क्वार्क्स, जो हम बोलते हैं सबसे स्मॉलेस्ट क्या है व्हेन वी टॉक अबाउट एटम. एटम के अंदर रहते हैं प्रोटॉन्स, इलेक्ट्रॉन, न्यूट्रॉन्स, और उससे बने हुए रहते हैं क्वार्क्स. सो क्वार्क्स जो रहते हैं ना, दोज आर द gluons. Gluons actually क्या करता है? It is the elementary particle which is the exchange particle between quarks.
एंथनी रहता ना, पॉजिटिव नेगेटिव जीरो.
Yes sir. हाँ.
क्वार्क का स्पेलिंग लिखने को बोलो इनको बच्चों लोगों को. क्वार्क मालूम है क्या?
भैया क्वार्क का 0 नहीं रहता, सिर्फ पॉजिटिव और नेगेटिव रहता है.
नेगेटिव
3 रहता ना क्वार्क्स.
हाँ भैया, मतलब
डाउन रहता. हाँ सर.
तो 1/2 ना, ऐसा कुछ रहता ना. वैल्यू क्या रहता?
हाँ भैया, प्रोटॉन में दो डाउन रहते हैं, और
yes, 3 invisible particles radiated from the sun, 3 quarks
कप
रहते हैं.
रहता.
Yes,
प्रोटॉन का जो 2+1 पॉजिटिव चार्ज देते हैं प्रोटॉन में, और न्यूट्रॉन में वो सब कैंसिल करके 0 देते हैं.
okay. So this is a very important 4 fundamental forces as short range strong force, फिर electromagnetic force, फिर short range weak force, और finally gravitational. ठीक है. So the strongest of all them is the nuclear force which holds the nucleus together. ठीक है. Then What is the next question? Discovery of the nucleus of an atom was due to the experiment carried out by dash. Who discovered the nucleus? Yes, what is the correct option? A, B, C, D. Okay, very good, Devra. Yes. Correct. Okay, the correct answer is B, Rutherford. Yes. Rutherford was the one who is attributed for the discovery of the nucleus. All right. The atomic orbital is dash. What is atomic orbital? Okay. Om, please check your answer.
तो इनको ऑर्बिट और ऑर्बिटर का डिफरेंस बताया क्या?
हाँ, ओके सर, मैं यही बताती हूँ. सी ऑर्बिट is the shell जिसके बारे में हम बात कर रहे हैं जिसमें इलेक्ट्रॉन प्रेजेंट है. ओके, सी इफ वी हैव द न्यूक्लियस इन द सेंटर, तो फिर जिसमें द शेल्स दैट वी ड्रॉ, ओके, द एनर्जी लेवल्स दैट वी आर ड्राइंग, इनको हम बोलते हैं ऑर्बिट. ठीक है, बट ये पूरे ऑर्बिट में इलेक्ट्रॉन कैन बी प्रेजेंट एनीवेयर, राइट? सो the maximum probability where we can find an electron, that particular region is known as orbital. Okay, so orbital is just a region in the entire shell में कहीं भी रह सकता है जहाँ पे हमको इलेक्ट्रॉन मिलने की probability maximum है, right? And the entire shell is known as orbit.
प्रोबेबिलिटी का दूसरा नाम क्या है? अभी हम लोग प्रोबेबिलिटी पढ़ते हैं, तो प्रोबेबिलिटी का दूसरा नाम क्या होता है? प्रोबेबिलिटी का व्हाट इज द नेक्स्ट नेम ऑफ प्रोबेबिलिटी? एनीबॉडी? इंग्लिश में प्रेडिक्शन, और क्या नाम हो सकता है? पॉसिबिलिटी, और क्या हो सकता है नाम उसका? पॉसिबिलिटी, प्रेडिक्शन और चांस. वेरी गुड, चांस इज अ वेरी गुड वर्ड. और सबसे अच्छा वर्ड है गैम्बल. लिखो, गैम्बल का स्पेलिंग जो लिखेगा ना इंडिया पास है. क्या गैम्बल का स्पेलिंग गलत है वो? हाँ, वो गैम्बल है ना, वो गेम का गैम्बल होता है. GAMBOL लिख, GAMBOL. या continue, Busha.
Yes, sir. The correct answer is the region in which there is a maximum probability of finding an electron. Yes. Somebody, I'm sorry, we can't hear you. Yes, please check your connectivity. Okay. So atomic orbital क्या है? It is the region in which the maximum probability of finding an electron. उस region को we called it atomic orbital. Okay. And orbit, please don't get confused. K, L, M, N, those are the orbits. But orbital, there are 4 orbitals, S, P, D, F, जहाँ पे हमको maximum probability है of finding an electron. Okay. In isotopes, the number of neutrons are dash. Okay, very simple. In isotopes, the number of neutrons are dash.
Different B.
Correct. The answer is B, different. Right. If asked in place of this number of protons पूछा तो that will be same, right? Species containing same number of electrons are
C.
Correct. Very good. Isoelectronic. Okay. In which one of the following is the valence electronic configuration NS2-NP3 found? NS2-NP3. Valence electronic configuration अगर हमको चाहिए, which of the elements will have the valence electronic configuration NS2-NP3? Yes, correct. Very good. Okay, I'm getting some answers N, some I'm getting C. Right, C is the symbol for C, or you all are asking for the option C?
Option C.
Yes, nitrogen, correct. Nitrogen. What is the atomic number of nitrogen?
7.
Right. So first shell mein there are 2 electrons, that is 1s2, and second shell mein we have 5 electrons, ns2 and np3, that is 2s2 and 2p3. Right. N is the correct answer. Okay. The nucleus of a singly ionized carbon atom contains dash. Singly ionized carbon atom contains what? Yes, thank you, Devrai. That was N1s2, 2s2, 2p3. Yes. A or D? Or
A.
B or C? What? Okay, Aryan. Why D? Can you please tell me, Aryan, why D?
A.
Okay. Yes, A is the correct option. See, Whenever I'm talking about singly ionized carbon atom, that means a carbon atom from which one electron has been removed. Okay, nothing is changing with the protons and nothing is changing with the neutrons. Either an electron is added or an electron is removed. Yes. So in that case, the only option that is correct here and the most appropriate one is option A, that is 6 protons and 6 neutrons. Okay, no problem, Aryan. All right. Match list 1 with list 2 and select the correct answer. Yes. Yes, please correct the match the discoveries, who discovered what, and accordingly tell me the correct option. Okay, Devraj, C. Okay. Some are saying option A. Okay. Alright, the correct answer is, I'll just match it for you all. Electron, we saw who discovered electron?
Sir Thompson.
Right. Proton?
J.J. Thompson.
J.J. Thompson.
Goldstein.
Goldstein.
Correct. See, actually, there's a, when I told you all, I talked about proton being discovered by Rutherford also. Actually, what happens is, regarding the proton discovery, there is, actually credit goes to Rutherford. But also Goldstein was the one who gave a theory long before Rutherford, but actual discovery Goldstein had done. Yes, Goldstein was the one who gave actual theory, but he was not able to recognize it as a proton. Yes, a group of scientists discovered it, correct. Rutherford is given the actual credibility for discovering a proton. Okay, neutron? Yes, who discovered neutron?
Chadwick.
Correct. And positron is Anderson. Okay, so the correct option is A.
दूसरा इसका सट्टा क्या है? अगर
Yes,
अभी
sir.
मेरे को कोई एक आंसर मालूम है, फॉर एग्जांपल न्यूट्रॉन किसका है? चैडविक का है ना?
हाँ, yes sir.
अभी न्यूट्रॉन चैडविक का है, तो C3 है ना?
हाँ, तो वो हो गया.
एक ही केस में C3 है ना?
केस में, हाँ.
तो वो बाकी के सब आंसर ऑटोमेटिकली आ जाते हैं.
Right.
आप समझे क्या?
Yes sir.
बताओ बुशरा, एक्सप्लेन सट्टा, व्हाट डिड आई से?
Yes sir. Sir talked about, see, we know that even if you don't know for all of these, even if you know one of these, like suppose अगर तुमको पता है, like for neutron का correct answer क्या है? Neutron किसने discover किया? It was Chadwick who discovered neutron. Okay, so we definitely know कि C का correct answer 3 है. So we check in the options कि कौन से वाले में C का third है, and you get that only one of them has C as 3. मतलब कि जहाँ पे neutron is discovered by Chadwick, and that will be the correct answer. That will be the satta that you can use for.
और ये भी बताना, अगर आपको 2 आता है तो 2 के लिए चेक किया करो. कभी-कभी एक ही वैल्यू हो सकता है.
Yes, कभी-कभी क्या हो सकता है, अगर suppose यहाँ भी 3 आ गया. So what you can do is electron, you all know J.J. Thompson is done. Okay. So that also you all can check कि कहाँ पे हो रहा है. So 2 again. Like if you can check, अगर electron का अगर हम check करें, okay. Like if you go first for using the satta, अगर तुम electron के लिए use किए, electron you all know it is J.J. Thompson. But you can see option A also and option C also, दोनों में A के लिए 2 दिया हुआ है. So what you can do is you can specify with option C. C के साथ तुम लोग clear कर सकते कि that is given by Chadwick, और वो option A वाला correct है. Okay?
No रट्टा but सट्टा, लिखो ना ऐसा.
Yes.
कुछ बच्चे लोग चैट बॉक्स में पूछ रहे हैं.
Yes sir. My positron is the one that is released in beta plus decay. Okay, see positron, whenever I'm talking about positron, actually, yes. Okay, 1 second. What are you asking? Is the one that is released during beta plus decay. Okay, actually alpha beta decay. Positron में क्या हो रहा है? That is the anti-electron. ठीक है? वो कब release होता है? I'll just tell you. Positron emission कब होता है? That is released in gamma radiation. Yes, what is beta and decay? Okay. Yes. Positron is the anti-electron. ठीक है? वो anti-particle है, या फिर that is the antimatter counterpart of the electron. तो electron का जो anti-particle है, उसको बोलते हैं positron. Okay? Yes, and that is possible in gamma decay. Atoms in which the number of protons is same but the number of neutrons is different are known as dash. Yes, the atoms in which the number of protons is same but the number of neutrons is different are called, yes, correct, this was easy. Isotopes is the correct answer. Yes. All right. And lastly, there are 6 electrons, 6 protons, and 6 neutrons in an atom of an element. Okay. Element X में कितने हैं? 6 electrons, 6 protons, and 6 neutrons. What is the atomic number and mass number of that element?
12(6)B.
क्यों बोलते हम 12(6) कार्बन के साथ क्यों कंपेयर करते हैं एटॉमिक वेट को? बुशरा तो एक दिन बता रही थी ना?
Yes sir.
हम लोग 12(6) कार्बन को क्यों झुकता मात बोलते हैं? वजन काटा रखते हैं ना, वजन काटा भी 1 किलो वजन काटा रखा अपन ने।
हाँ।
और आपको
क्योंकि
6 एप्पल रखे।
Avogadro number of molecules रहते हैं सर। उसमें
हाँ,
exactly Avogadro number of
ये
molecules।
बच्चों को नहीं मालूम 12(c) कार्बन में एवोगाड्रो नंबर रहते हैं, मालूम नहीं है। कितने लोगों को पहली बार मालूम पड़ा? दूसरा वापस से बोल।
Yes sir. जब भी हम लोग बोलते हैं कि 1 mole, what is 1 mole? We take it 1 mole is that number, or you can say that number of particles है उसमें जितने की 12 grams of carbon में रहेंगे। Why 12 grams of carbon? Because if we check that 12 grams of carbon, उसमें exactly Avogadro number of particles रहते हैं। So indirectly what you are implying is हम क्या बोल रहे हैं कि जितने particles Avogadro number में है उतने ही particles 1 mole में रहेंगे, right? And because 12 gram of carbon contains exactly Avogadro number of molecules, that is why you say that the 1 mole of any particle, 1 mole of any element will have 12 grams of carbon में जितने particles रहेंगे उतने ही particles 1 mole में भी रहेंगे। Yes, that is why we take carbon 12 for Avogadro numbers also. Okay, clear everyone? Yes, what is the correct answer for this one? Atomic number is 6 क्योंकि number of protons हमको मालूम है, it is given as 6, right? Yes, it is B. All right. Yes, actually, yes, it should be atomic number is 6 and mass number is 12. I'm extremely sorry. Yes, Devrai, correct. The correct option should be 6 and 12. Yes. All right. Yes.
612 ही कार्बन है।
Yes, sir. Yes.
कार्बन को 12(6) लिखता है ना? हो गया तेरा और है?
Yes, sir. नहीं सर, हो गया 10 questions.
Thanks, Bushra. It was a very fantastic presentation.
Okay, thank you, sir.
All of you, biology, geography class is starting. So please join the geography class. Any questions you have to ask? I'll give you a minute. Anything more you want to know? Just check the chat box if you want to know something.
Yes, sir. Yes,
Attendance लेके देखो जरा.
sir. Thank you, sir.
हाँ? लैपटॉप में लो, फोन पे लो, कहीं पे लो. फैजान सर, आपने अटेंडेंस लिया क्या? Bushra, you're taking from the phone or from the?
From the laptop, sir.
Can you take the attendance participant का?
Yes, sir. So अभी तो I think most of them have left. It is 78 only.
Yeah. फैजान सर, geography lecture.
Yes sir.
Attendance लिया क्या फैजान सर आपने?
सर अटेंडेंस नहीं लिया।
नहीं, अभी अटेंडेंस महेंद्र सर नहीं लेंगे, आप ही लेंगे।
ठीक है,
आप ही लिया करो, तो आपको पता चलेगा कौन बच्चा आ रहा है, नहीं आ रहा है, कौन सा बच्चा फेक है
जी।
अभी अटेंडेंस लेने के बाद आप उसको बंद कर देना।
Bushram, are you taking the attendance?
Yes, sir. Yes, I'm taking a video. Yes, sir. 1 second.
फैजान सर, आज से सब सारे अटेंडेंस आपको ही लेना है।
Yes sir.
Yes, sir. पर अभी तो ज्यादातर तो
क्या होगा, आपको पता चलेगा फेक कौन है, कोई फेक आईडी से आ रहा क्या, एक ही लड़का कोई 2 नाम से आ रहा क्या, सारी चीज पता चल जाएंगे आपको। ठीक है फैजान सर?
Yes sir.
Yes, sir. Thank you, sir. All right, sir. I've taken the attendance.
Yeah. You can send it to Faidan sir also.
Yes, sir. Yes,
Thanks.
I'll send him the video.
And send it to me also.
Yes, sir. Yes, sir. Yes,
Bye.
I'll send it. Okay, sir. Okay.
अच्छा presentation था। Inshallah, tomorrow there will be the last presentation by the teachers and students. From 15th of August, Independence Day, we are going to do only mathematics presentation for a week's time,
Yes.
because ND exams are coming.
Yes, sir.
ठीक है।
ठीक है, sir.